The law of force existing between two electric charges was established from the results of the experiments performed by Henry Cavendish in 1772 and Charles Augustine Coulomb in 1785. This law is known as Coulomb's law. It can be stated as the mutual force existing between two-point charges Q1 and Q2 is proportional to the product of these charges Q1, Q2 and inversely proportional to the square of the distance r between them. Let Q1 and Q2 be the like charges. The mutual forces of repulsion existing between them are illustrated in figure. Here vector F21 is the force on the charge Q2 exerted by the charge Q1 and vector F12 is the force on the charge Q1 exerted by the charge Q2. Note that the unit vector r cat vector 12 in the direction from Q1 to Q2 is on the line joining both the charges to represent these forces as vectors. In figure, it is clear that r cat vector 12 is equal to vector r2 minus r1 upon modulus of vector r2 minus r1, where r is equal to modulus of vector r2 minus vector r1. That is equal to vector r12 upon r. Now we can write these forces in the vector forms as force on Q2 due to Q1, vector F21 is equal to K into Q1 Q2 upon r square into r cat vector 12. Force on Q1 due to Q2, vector F12 is equal to minus K into Q1 Q2 upon r square into r cat vector 12. Therefore, vector F21 is equal to minus vector F12. Here K is the constant of proportionality. If Q1 and Q2 are measured in Coulomb, R in meters and forces in Newton, the experimental value of K is 8.98754 into 10 raised to 9 Newton meter square upon Coulomb square. That is equal to 9 into 10 raised to 9 Newton meter square upon Coulomb square. To avoid writing 4 pi in several formulae of static electricity, K is expressed as 1 upon 4 pi epsilon 0, where epsilon 0 is the permittivity of vacuum. Epsilon 0 is equal to 8.8854185 into 10 raised to minus 12 c square upon nm square. That is equal to 8.9 into 10 raised to minus 12 c square upon nm square. If two charges are unlike, considering Q2 as negative, vector F21 is equal to K into Q1 into minus Q2 upon r square into r cat vector 12. Therefore, vector F21 is equal to minus K into Q1 Q2 upon r square into r cat vector 12. And vector F12 is equal to minus K into Q1 into minus Q2 upon r square into r cat vector 12. Therefore, vector F12 is equal to K into Q1 Q2 upon r square into r cat vector 12. These forces are shown in figure